Hi everyone. My name is Jiaxin. I'm currently a postdoc at Stanford Digital Economy Lab. This is the work I did like last year when I was interning at Bloomberg. While we have Bloomberg logo here, I have to say that what I'm saying like do not represent Bloomberg's opinion. So, and probably this is one of the few paper that don't have AI in the title, but it's actually looking into AI. So I'm very excited to talk about this work. And it's already published at NAACL, is a Frontier Natural Language Processing Conference. So the motivation of this paper is very straightforward, that in finance and corporate operations, it's very important for us to measure the company's risk. And like investors, hedge funds, traders, like employees, they all care about the risk of a certain company. And there's been many work trying to analyze company filings like 10K, 10Q annual report, shareholder meetings, trying to understand and extract those risk factors from this textual data. But there are several core challenges or issues regarding all of this like data, because the first thing is company filing is very low frequency. You only get those data every 3 months or every year. And it's like very subjective. You only get those data. Those are self-report data that has been censored, that has been has been seen like by many kind of like companies shareholders, right? And also it's only required for public companies, like for the company who are listed publicly. So it's rare for you to get those information for private companies. But a lot of cases we do hear about private companies like Huawei or TikTok, those like or maybe like Bloomberg, right? Those like private companies are very powerful and people curious about the risk of these companies, or because these companies are standing on the supply chain of many other companies. So we believe that news article offers a very unique opportunity to measure the company's risk. First, it's a real time, it's very frequent regarding the publication cycle. If you can get like the risk factor of news article, like from news article, sometimes you can attribute an event stream that maybe trigger certain stock trading, right? Very important for hedge fund. And also you get the perspective from outside. You get those from journalists, from analysts, from like different perspectives. So it's very diverse. And also it covers like both public and private data, like companies. You not only get those like Google or Apple, you also get TikTok. So in this talk, I'm going to talk about how to use NLP to identify company risk from news. So we're going to talk about the type of risk that we care about, and then I'm going to talk about the natural language processing pipeline to model risks. And then I'm going to talk about some application analysis we did to show that this pipeline is actually working, and there are some interesting insights you can actually draw from analyzing news articles. So it's very straightforward. Like based on the existing literature, we came up with like these 7 core category risks that people actually care about regarding a company. The first is regarding supply chain and product. They focus on like certain risks regarding the manufacturing, product quality, core technology, the supply chain of a company. The second is regarding people and management, regarding layoffs, like maybe CEO resign, or maybe management strategy of these people-related and management-related risks. The third one is regarding finance, regarding whether the company's cash flow is healthy, whether it's making meaningful product, like profits, regarding the investment and capital. And the fourth one is regarding like legal and regulation. We've seen like so many like new policy about AI, which is like very important for all the operations. Like for example, like the recent EU Act is going to affect a lot of like AI companies in Europe. And regarding the macro risk, like going through COVID, we have seen so many like companies, like the whole industry is being affected by COVID. So also curious about like, how this like macro risk will affect certain companies and industries. And the last two are market and consumers. That's a very intrinsic like dimension like for us to model company risk. And the last one is competition, like whether we're seeing some competition and some competitors like in the similar industries for a certain company. So basically, these are the 7 type of like risk category we're curious about. And the basic task setup here is given a news article. For example, this is a news article about Tesla, and we already know the company. Like so, basically, we have some internal NLP pipeline to identify which company is mentioned here in this news article. And then the goal is based on this news article and the company, we're going to analyze. We're going to map this news article to the 7 categories, like whether the companies, like for example here in this case Tesla, is having certain like type of risks. And we're going to build an AI model that allow us to automatically analyze these risk factors. For example, in this case, we see that like Tesla is seeing supply chain and product risk and also the market and consumer risk because we see there's like concern regarding the demand. So how are we going to do that? You guys are probably super familiar with like the standard like supervised machine learning pipeline. So here we build a new like natural language processing data set. It's like a benchmark data set with 713 Bloomberg News article annotated by domain experts. So it's very hard to annotate, so we can't get a really larger data set. But it's very evenly distributed across these 7 categories, like except for computation. It's just like such a rare category, like not actually mentioned in news articles. We had like a really dedicated like sampling pipeline which makes this happen because the natural distribution of risk factor in news articles is like below 3%. So we won't go into the detail about the data sampling. If you're interested, you can check out the paper. But the short story here is we build this data set. This data set allow us to evaluate the AI model we build, also to train an AI model that can help us to identify the risk factors. So can we use AI to automatically identify risk from news? So first, we are going to talk about some like baseline performances, like the, and also we're going to talk about how we like prompt certain LLMs. We have like MPT-7B. This is like last year's model from Mistral. FlangUL2 is a model from Google. Llama 2 from Meta. Well, we wasn't able to use ChatGPT or Gemini for like some legal reason. But I'll say like Llama 2 is pretty good. Like FlangUL2 is pretty good comparing with this like the models in this year. So like the numbers are still generally valid. And also we experimented with like several fine-tuning language model options. Like we fine-tune all these like Roberta model, BERT model, and also like it like was mentioned that like the Roberta large BB is like a domain specifically fine-tuned internal Bloomberg model. And so here we can see the results that we're going to start from the baselines. We see that the overall macro F1 across all the risk factors, for all these baselines, it's very low. Like 0.4 is like a very low number. Like basically you can't use this in any products. And then we're going to see that the LMs, how the LM are doing, actually they're not doing that well. For example, like for Llama 2, it's actually like even worse than like the logistic regression model. So I guess like this is probably because like these models are not specifically fine-tuned on this like financial task, and the identifying risk is actually requires some like reasoning about like what's this like word actually mean regarding risk factors, and it was actually very difficult even for domain expert to annotate. But if you see the domain specifically fine-tuned like language models, we actually see that we're seeing like way higher performances. We train this model, we fine-tune this model on our training data. We actually see like the best performing model, which is like a domain specifically fine-tuned Roberta model, can actually obtain like 0.6 macro F1 over all the risk factors. So I guess like a takeaway here is like sometimes it is still meaningful to use this like smaller size domain specifically fine-tuned models. So I have one slide for this, like why not LLMs, right? Like that's probably a lot of like you are actually curious about. I think there are 3 major reasons like why LLMs may not be super suitable for this task. The first is actually latency. Because like we want real-time data stream for a company risk, right? Imagine like you're a hedge fund, you want to build a trading strategy and you receive the data stream like that will automatically trigger this trading. Right? You want like really low latency, but the LLMs, they are quite slow, right? Like GPT-4, GPT-4o are quite slow. But those like smaller size LLMs, they're quite fast. And they have very mature infrastructure to make this happen. The second is cost. Like smaller size LLMs are cheaper, right? Like when we're thinking about like the news data, we're thinking about potential like hundreds of thousands like news articles per day, and we want to analyze each of them. So you do need like a very fast. You also want to minimize the cost. So that's why smaller size LLMs might be actually more helpful in this case. And another one is like accuracy. I think this is not just this paper, but many other papers have shown that on many types of tasks, like just using the general purpose LLM, or if you do few shot prompting, zero shot prompting, even chain of thought, it's not like the optimal way to do it. Like if you fine-tune this, fine-tune a smaller size model on a domain-specific data, that's always the optimal way to obtain the highest accuracy. So for these like 3 reasons, we believe that like actually using a smaller size fine-tuning AI might actually be better than just use ChatGPT. So what can we do about this model? So we try to analyze a large data set. This is like a Bloomberg News data set from 2018 to 2022. It covers like the whole COVID-19 period. And we also filtered out machine-generated content. And one really nice thing here is like you can see that it's actually a very balanced data about both public companies and private companies. So like private companies actually get a lot of mention in news articles. So first thing we did is like, yeah, can we analyze the company level variation of these risk factors? So here are 2 examples. The first one is regarding Toyota. So we all know that like during like the 2020 is like the birth of COVID-19, which also lead to like the whole global like chip shortage. And we see that like for Toyota, like starting from like 2020 is like the peak of the macro risk, but then the macro risk dropped because like it's like the 2020 is like the birth of the COVID-19, but we see like the supply chain risk like slightly increase because of like the chip shortage. However, like for Huawei, like in news articles, like Huawei is like seeing like really high regulation risk like throughout years, potentially because of like the US sanction to Huawei. But we are also seeing like generally higher macro risk for Huawei, like starting from 2020. So this is like just some example showing that how we can actually analyze company related risks using these news articles. And then once we aggregate this company level risk factors, we can this actually allow us to take a closer look at the different risk factors at the industry level. For example, you can see the first plot is like regarding healthcare. We see like very high legal risk and supply chain risk for the healthcare industry, but we're basically seeing 0 supply chain risk for the financial industry. I mean, because there's no clear like supply chain or they're not making real like physical products. But we're seeing like very high legal and management risk for the financial industry. Yeah, so like for all of these industries, like basically like analyzing news article allow us to really flexible way to build an index to understand the risk factor across the industry. Another very interesting thing we can do is if you further aggregate all the industries, all the companies, this actually allow you to analyze the macro risk that a certain society is facing. If imagine you're analyzing maybe S&P 500, or you're analyzing the stock from China or stock from Europe, this actually allow you to looking into like a societal risk, like from the perspective of company operations. So for this plot, we're showing like the overall variation of different type of risks across COVID. So we see that there's one prominent event that is like in 2020, like this, the January 30th is like the first time where WHO declares the global health emergency. So you can see that at that time, all the other type of risk, except for the macro risk, so macro risk start to rise at that point after the declaration, but all the other risks are still remaining at a relatively low level. However, after the rise of like the huge macro risk after like 2020, like after the March 11th, and especially after like after the mid of 2020, we're seeing like the rise of other type of risk and also the peak of the macro risk arise at around like April 2020. So this plot actually captures like the societal level variation of different types of risks from the perspective of company operations. So yeah, so these are just like some interesting things you can do and explore with this tool and with this like news level company risk factors. And so the major takeaway here for this study is like we have this new risk categorization framework. When you want to think about like analyzing risk factors from news articles, you can try to maybe analyze those from the 7 dimensions. And also we build this new data set and model. We show that actually in this task specifically like fine-tuning large language models can actually be better than just prompting those like super big like models. And also we show that like if you analyze this data, it can actually give you a lot of like new insight about companies, industries, and the societal level variation for risk. And this is like still a very initial like early phase of this study, and we don't look into any like stock variation or maybe market volatility. And we'll be very excited to see like more follow-up work in this direction, looking into the news factors in risk factors in news articles. Yep. And so if you're interested in reading the paper, here's a QR code you can directly scan, and that will lead you to the paper. There are a lot of technical detail in the paper, and yeah, I'm happy to take any questions.
Could it identify and remove generated content?
Yeah, there are some like Bloomberg internal pipeline to do that. Yeah. Oh, okay.
Could it use a rules-based approach to election and
So it's not a rule-based. Like, it's basically, so Bloomberg has like a really big. I'm not sure if I can say this, but yeah, they have some like a really big list of like the different like companies, different industries. Those are already using other Bloomberg NLP products, and so we directly adopt this pipeline to extract those.
Okay. So I have a quick question. Thank you so much for your presentation. I was wondering, it's called concept here is that you use news to predict risk, but then you're kind of in a positivity bias, so to speak, because you only based on information that is available. So, for example, Toyota has not had recalls on their models maybe for 10, 15 years. There won't be any article about this, but it's strengthening their positioning.
Mm-hmm.
So maybe you are underestimating their position because, there won't be news about it, right? So there are multiple situations like that. For example, the fact that you have not produced a new product is actually news, even though it's not being discussed. It actually says something about potential decline, risk organization. So I'm wondering, how do you leverage this kind of track that something is just not there?
Yeah. I think that's a really good point. I guess the baseline we're comparing with it's like company filings. There's a tons of studies have already shown that how this company filing data are very important to measuring like the certain stock return or maybe like the company level outcomes. But like our argument is like news data is just like providing a better solution compared with like the company filings, but we're not providing the ultimate solution. Like, I mean, information is always the key, but a news article is definitely faster than the company filing data. And imagine you're maybe like part of like a hedge fund, and a lot of times you want to build those kind of like automatic like trading strategies that are triggered by certain event. And this to actually allow you to, from like, let's say there are like a million articles every day, and you're seeing like 10K companies, and which one you always want to find those events that are triggering the stock volatility or stock change, right? So with this model, you can actually automatically identify those signals that will lead to the market change. But there are always like people who get the early information about this certain company. They are probably the fast movers. But yeah, those information are not just available on the market. But one potential interesting case might be maybe from social media data or from some other sources data, and we believe that like extending this NLP pipeline to measure social media data, maybe other source of data can actually also help us to make this like whole measurement of company risk better.
And I'm also thinking about the knowledge domain and how in-depth this models can analyze the risk based on just a small subset that you use. So say maybe Boeing is buying a new company that will produce parts for that. Mm-hmm. And this will drop their quality. If you're an expert, it will lead to disaster. But from your perspective, they bought something that's good with new
Yeah, I think that's another level of studies. Basically, we want to I think like all the analysts are trying to make sense of like certain like companies' actions, and a lot of analysts, they may actually disagree. And I guess that's also something we might be able to use LLM to do, is like relying on LLM's reasoning capability. Maybe we can build some automation to reason, like to make a causal chain from like certain action which seems to be neutral, and whether that will lead to a positive or negative outcome in the end. I would say that's so in the data when we're modeling this, like the part of like this reasoning is incorporated based on the domain experts annotation, right? When they are seeing this event, they will think about, okay, whether this is leading to a positive signal or whether this is leading to a risk, right? So basically, we're incorporating this in a data-driven annotation pipeline. But yeah, maybe using LLM will be a better solution, and I believe that we're just like on the way to make this to create this automation. Yeah.
That's so cool.
I think
Word.
we're up. So thank you.